Welcome everyone to Dr. Scott's Maths Made Simple. A young viewer requested that I do parabolas, and I'm going to do that, but I thought before we do parabolas we should briefly touch on ellipses and hyperbolas. So this is ellipses and hyperbolas. An ellipse is an oval shape like that, drawn basically on the graph with an x-axis and a y-axis. And an ellipse has two foci. Focus 1, focus 2, F and F1, whatever you want to call them. They have two foci, any ellipse. And if you draw a straight line from one focus up to the edge of the ellipse and then down to the other focus, if you add those two distances together, you'll always get the same number. So P plus Q will always equal a constant. Let's call it K. P plus Q equals K. Even if I drew it up here and over here, or down here and across there, whenever you add them all up, even if I went to the axis there and up to there, you add those two lines together, or the sum of the two lines, and you'll always get the same number. That's the definition of an ellipse, with two foci, and that number will always be a constant. If you want to think of an ellipse in very basic terms, the general equation you could say would be x squared divided by a squared plus y squared divided by b squared equals 1. That's the general formula of an ellipse. Okay, the general formula of a hyperbola, which I'll show you in a minute, which looks quite different, is x squared over a squared minus, ellipse is plus, minus y squared on b squared equals 1. So, since I mentioned hyperbolas, I'm going to draw one just to show you. They sort of come in twos, so it's sort of like this, and out like that, and sort of like this, and out like that. Now this is a hyperbola. Hyperbola 1, hyperbola 2. And this, the red one, is an ellipse. So I'll just put E there for ellipse. So just while I'm mentioning it, the general formula of a hyperbola is x squared on a squared minus y squared on b squared equals 1. Hyperbolas also have two foci. Foci is just the plural of focus. So we have focus 1, focus 2. So just looking at the black lines at the moment, they're the two hyperbolas. Now the difference is that if you add you subtract the two distances from focus 1 up to that line and down to there, if you subtract them, you'll always get a constant. So in this case, we could go like this and up to there, like that. And we could get P, we'll call that P and Q. We'll call it the same, even though it's quite a different thing I'm talking about. But we find that P minus Q equals a constant, again, no matter where you go. So you go to there, go back from one focus to the line of the other hyperbola, and up to the other focus. You can go further out and go back again, but when you subtract the two, you'll always get the same number. Whereas with an ellipse, when you add them together, you get the same number. With hyperbolas, when you subtract the two, you get the same number. So, just concentrating on the red ellipse now. So, we're just doing the ellipse at the moment. If you were given this equation, 4x squared plus 18y squared equals 36. Now, that's actually an ellipse. But how do we get it back into our general formula? X squared on a squared plus y squared on b squared equals 1. Well, first of all, the 36 needs to become a 1. We need a 1 on the right. So we divide everything by 36. So 4x squared on 36 plus 18y squared on 36 equals 36 over 36. Now you can see, if we take it across a bit here, we go across here, we keep going with this equation. So 4 on 36 is 1 on 9. So 4x squared on 36 equals x squared over 9 plus 18 on 36 is 1 on 2, 1/2. So again, equals y squared over 2 equals 1, because 36 on 36 equals 1. Now we have it in our general form, our general equation, the form of our general equation. So x squared on 9 plus y squared on 2 equals 1. So this is the equation we started with. 4x squared plus 18y squared equals 36. That is an ellipse. This is it in the general formula of an ellipse. Let me ask you something. What if y equals 0 in this equation? Well, when y equals 0, you've got this point, but you've also got this point. And you can see that if y equals 0, then x squared on 9 equals 1. You can ignore that because y equals 0. X squared on 9 equals 1. So, in other words, x squared on 3 squared equals 1. That's a bit confusingly written, but the point I'm trying to make is if you multiply both sides now by 3 squared, you end up with x squared equals 9. So if y equals 0, you end up with x squared equals 9. So x can either be 3 or minus 3. So 3, 0 is one point on the ellipse, and minus 3, 0 is the other one. And you can do the same. You can do the same letting x equals 0, because when x equals 0, we're either here or we're here. So when x equals 0, y squared on 2 equals 1. I'll just show you that. Y squared on 2 equals 1. So therefore, y squared equals 2. So y equals root 2 or negative root 2. So that would be 0 root 2, and this would be 0 negative root 2, x and y. So that's looks very complicated. The general formula of the ellipse is that. The general formula of a hyperbola is this, and with an ellipse the two lines add up to the same number every time, a constant. With a hyperbola, the two lines from the foci, when they're subtracted, give the same number. So that's ellipses and hyperbolas in a nutshell. Part of the reason I spoke about these is hyperbola sounds like parabola, but they're very, very different. And I just wanted to touch on them both to show that they are different. Okay, thank you, and next we'll do parabolas. Just have a break. Thank you. Bye.